for whatever reason it's working.
Hello, Rob. How are you?
Hi, Marcelo.
How are you, my friend?
I'm well.
Oh, good. Very good.
You've been studying?
Excuse me? I didn't listen.
Okay. So the purpose of this.
Hello? 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 I didn't hear you. I don't hear you. Hello? Hello? Hi, Rob. Are you hear me? Hello?
Marcelo, I show you on. Hello, Marcelo.
Hello, Rob.
There we are. Okay.
Okay?
I'm going to share my screen.
No, no. I'll only your picture.
Well, yeah, I've just started sharing. You tell me when you can see it.
Okay.
See?
Okay. I'm seeing your screen now.
Okay. So I'm just going to go through the user guide.
Oh, in Portuguese.
You in Portuguese, so you can, I know what it says, so I don't have to know the Portuguese. Okay.
Okay. Okay.
So yesterday we talked about lactic acid as an antimicrobial, and you remember. Hopefully, what you remember from that is been used in the beef industry a long time.
Yeah,
It,
yeah.
it's part of a sequence of steps that reduce the risk of E. coli,
Yeah, yeah.
and it's generally applied very lightly in a mist pattern
Okay.
through. And so this guide. Have you had a chance to review this?
Okay.
I sent you this yesterday. Did you get a chance to look at
No,
it?
I didn't see. I didn't receive this.
Oh,
No, in my email.
yes.
No, I didn't receive. Let's check again, but I didn't receive.
Okay.
No.
Okay. So this is what you're looking at, Marcelo, is a draft that
Mm-hmm.
Fabiola in our office has been editing.
Mm-hmm.
So there may be some words here that are, I think it's translated correctly,
Yeah.
but yet there may be some terminology that's specific for the meat industry that doesn't fit here. So
Okay.
if you see anything that is out of place, I'll have you email Fabiola.
Okay. I don't have email of Fabiola, but I can do a contact with him with
Yeah,
her.
or Raphael or anybody.
Mm-hmm.
So the first this will be the book that we take to the plant and we give to the plant.
Okay.
Okay, so that this should have a resource that they need to answer questions and educate.
Okay.
And if you find that we need to create a slide presentation for you to share with your
Good.
countrymen, women, we can do that as well. But this was the start. Okay.
It's good. It's good.
So the introduction is really to talk to fairly small.
No, I can see. I can see. I can see.
Okay. So the introduction here is really about the many studies that we have in our library that show the effectiveness of lactic acid. So remember we talked about log reduction?
Yeah, yeah.
One log reduction is generally considered successful, and these are averages across many studies. You can see in the parentheses. For example, here we have 10 of these studies looked at E. coli STEC reduction on pre-chilled carcasses, or pre-chilled beef surfaces.
Yeah, yeah, yeah.
And of the 10, across all 10, the average reduction was 1.28 log. So of course the study designs are different, and that's not a statistically sound conclusion. It's just a simplified average.
Okay.
So that customers can understand that, okay, certainly as an average, there's going to be individual studies that have lower numbers and individual studies that have higher numbers. But I think overall, the strength of evidence is very, very clear that we get a 1 log reduction on these type of beef surfaces.
Okay.
In the chilled environment, you get a little bit slightly less average, but different studies, so probably not really different conclusion. There are 11 studies that way. One thing to keep in mind is for these indicator organisms, so coliforms and generic E. coli and total plate count.
Okay.
This is naturally occurring bacteria. You don't inoculate with total plate count. You don't inoculate with generic E. coli generally.
Okay.
So this would be more kind of representative of what the plant will measure. They measure, so you see the coliforms is less than a log. The coli is more than a log. And the total plate count is more than a log. And that's the degree of reduction is going to be subject to the amount of contamination. So if you're dealing with chilled meats, the coliform counts are not going to be very high to begin with. And it's really hard to go much harder to go from 2 logs to 1 than it is to go from 4 logs to 3. Because you're getting fewer and fewer bacteria. They're probably well hidden in the surface of the meat, and in getting the magnitude of the reduction to in those low count areas is a little bit hard to do. Plus the chilled meat it's harder to kill bacteria on chilled meat. So actually, if I would have guessed, I would have guessed that there'd have been a greater difference between these reductions. But you can see they're always higher on fresh meat. 2 reasons. The bacteria are more vulnerable. They're more newly attached and they're active. So they're in a state where they're metabolizing and can be more readily killed. They're not in a dormancy. Okay, and then the second thing is there's just more of them. Now in the STEC and the Salmonella, these are inoculation studies. So they've spiked the meat surface with a set quantity so they can control the study and predict. They can measure outcomes with fewer numbers of samples. And so this is these numbers are artificially going to be higher just because they're spiked samples. Okay. So anyway, it tells the story that we've got a lot of history and a lot of data to show that our product works.
Okay, all the studies is American studies?
Yeah. Probably. I'm looking at the list. There may be, I think there's a Chinese study in there, Zhao.
Okay.
Might be Chinese. Everything in the top is American.
Don't you have Brazilian studies? I think we don't have.
Let's ask Paulo and Rafael. I'm sure there are Brazilian studies done. They're probably published in Portuguese in a Brazilian journal, and
Yeah.
I wouldn't have.
I,
I
I,
personally wouldn't find them.
I will looking for. I will looking for.
But we could add some Brazilian studies to this easily.
Okay.
Well,
Okay.
send to somebody translates it for me. I can add them easily. So this page.
Hi, Robin. Hi, Robin. Here's Paulo. I got to attend this meeting, right? I just arrived right now. And yeah, regarding the Brazilian study, I believe that we don't have so many studies about that. I believe the best one that we do have is belong to JBS that they made in a university. Okay. But I believe it's a kind of a master degree of Renata. I believe she has good information about that, but I don't know if she can share with us, right?
Okay.
Because I believe that Renata now is working to GBS, and I don't know if we can have access for this study.
Okay, Paul.
Mm-hmm. So this is an explanation of how you set a food safety objective. And it gives you some math to work on here. But the point I want you to understand, you can read this on your own. But the point of it is that the way we know the value of a 1 log reduction is by considering the total reduction across the system that we want to achieve. And the way we know that is we set some target. So just like anything else, if we're trying to move from a current state to a future state that's different, we need to have quantitative ways of setting the goal and measuring the progress towards the goal. And so what this really explains is that we know that it's practically impossible to create a totally clean, risk-free food product. What is possible though is we can say, we want to have less than 1 cell in 325 grams of meat, or we want to have less than 10 cells in 100 grams of meat. We can set some quantitative objective to say, mathematically, we want to achieve this level of risk, and then from that, do a calculation backwards to what our starting risk is. So if we have a million cells per 300 grams of meat to start, and we want to get to less than 1 cell per 100 grams of meat to end, we need to have a 6 log reduction. We need to move that. We need to go from 1 million to 1, and that's 10 to the 6th. So again, you can think about that and we can do it gets a little bit hard to do the calculations because you have to go from contamination on a surface to contamination in a finished ground beef product, which is one's based on surface area and one's based on weight. Those are 2 different kind of ways of thinking about the matrix. But what's important here is to communicate to customers that what we're doing is whatever we measure in this intervention is contributing to that step down of bacteria that we talked about yesterday. And I think I've got another graph in here to show that. Whoops. In fact, yeah, it's the next. You'll recognize this from our conversation yesterday.
Yeah.
So we're showing them, it's like, what is your goal? Where do you want to be here at the end? Where are you potentially here? And they're not going to know. They're not going to know that the hides coming in have a maximum contamination of 6 log E. coli. They're not going to know that. Nobody knows that. It's been measured infrequently by universities and governments to try to establish what the worst case is. So what you do is you generally work off of the published results of those studies. So if the worst known case of E. coli is 4 log per 100 square centimeter on a hide, that's a super contaminated animal, then that's your start point.
Rob, just a question, because this is that appeared regarding when you say hides. What part you are talking about? Because we translated here as skin on the skin, but I don't know if it's a right translation.
That is the right translation, the skin.
Yes, the skin. Yeah. Okay. Because I was on doubt if we translating the right way, because we translate on the skin, right?
On the skin.
Is that okay?
Yes, of course. For us,
Uh,
skin doesn't really have hair on it. A hide has hair, so that's maybe why we use a different word. But we're talking about the animal as it walks around
okay.
and breathes and eats. A live animal surface.
Okay. No, that's what I was wondering, right? If hide could mean skin, yeah. But yeah, that's perfect. Great.
Okay. And then you have some details as to how we recommend applying the lactic acid. So we want to apply at as close to 55C as possible, 2 to 5%. And then you see the ranges of pressure and so forth. So customers will really stumble on this, because they want to know, well, if I don't apply it what if I apply it at 54C? Or what if I can't heat the water and only apply it at 20C? Is that wrong? Is that bad? And the answer is, it's not wrong and it's not bad. It's not optimal. So if we want to give ourselves the best chance of killing bacteria, we want to apply the 5% at the warmest we can get it, 55C. If you think logically about this, if you applied it at 80C, that'd be even better. Well, why don't you apply it at 80C? Well, because that would cook meat. That would cook the carcass. You don't want to cook carcasses. Well, why don't you apply it at 20%? Well, aside from the regulatory limit, that would damage the color of the carcass and be very expensive. So these are realistic, experience-based optimum ranges, but we want to be very careful to not have it. I've seen the customers do this before. They want to be very precise, and so they write into their HACCP plan, we're going to apply 5% lactic acid at 55C. And then their inspector, who might not have ever reviewed a HACCP plan before, in the case of, I don't know if that's true in Brazil, but an inspector that doesn't have good training comes in and says, oh, well, I took a sample of your lactic acid today and it was 52C and it was 4.5%. You're out of compliance with your own guidance. Therefore, you need to take a corrective action and retreat all of those carcasses. That's a disaster. That's a huge problem. And so
this is something that can happen here, because it's a totally new process, and the inspector are not very aware about that. So I believe that they are when we say that it's lower than 55, I think they can understand, right? Because it's very dangerous, because they can think that the temperature is different, right? It's lower than 55. And the same regarding the concentration, Rob. This is something that we have to be very aware here. Yeah. So
yes. So when we have customers set critical limits, and every an intervention is generally a critical control point. And for a HACCP trained person, there's an art to creating HACCP plans, because critical control points are necessary. They're part of the HACCP system.
Yeah.
And yet, when you call something a critical control point, it is critical. And that means if it doesn't happen the way you intend for it to happen, you have to take a correction step. And so the art of doing a good HACCP plan is to get the critical control points to have some flexibility in them. So the customer will want to say, my critical control point is lactic acid. I'm not going to run my plant unless the lactic acid system is working that day. But working means that it's applying 2 to 5% at 45 to 55C at 20 to 40 PSI pressure. We can convert that to metric. I don't know if you use PSI. It stands for pounds per square inch. You may use bar, which is kind of I think that's an international standard. So we can convert some of this if we need to. But in fact, it says bar, 1.4 to 2.8 bar, so it's both there. So they need to make sure that they're putting wide enough ranges in there that that they don't go over or under a limit in normal operation. Okay, but the art to this is that for every range that you put in there, you've got to justify it. You've got to say, well, show me that 2% works and 5% works. And that's where it comes back to Corbion, because we have all these studies, and some of them might say 2% works, and some of them were tested at 2% and 20 psi, and some were tested at 5% and 40 psi. So we have to show the studies that are necessary, or may have to produce the studies that are necessary that provide what's called a justification for the parameter. And I have my favorites in here. Not Bacon. Where is he? Curtis from Harris Ranch. Curtis. He's in here somewhere. I'm trying to remember it. I'm drawing a blank. Curtis. I think he's not in there. I don't see him's name. Should be. I don't see him. Anyway, it's not made the list for whatever reason. We can pull these studies and show them. Curtis Pittman, here he is. This one right here. Mm-hmm. Okay, this guy did a study. He's actually one of our customers now. He is the food safety manager for Harris Ranch Beef out in California. And Curtis Pittman did a study where he ran low pressure, high pressure, low temperature, high temperature, low concentration, high concentration. And what you see in that study is that the results are fairly similar. All of them are effective. And so you can pull that out and you can show that to the inspector, and you'll say, oh, well, I see that from Curtis Pittman's study here that the log reduction, I'm making this up, was 1.1 at 20 psi and 1.3 at 40 psi. You ought to be using the 1.3. Well, that's an opinion. The fact of the matter is that one log or better, or someone skilled in the art here would say, hey, anything that produced a log reduction was quote unquote successful, and therefore both parameters are appropriate. Okay, so why don't we just use the Curtis Pittman study and get rid of all this? Well, Curtis Pittman did his study on chilled meat. So the inspector says, well, this is a nice study, beautifully designed, but you show me that it's going to work on hot carcasses. Oh, well, then we got to grab the Dorsa study up here. So it's the combination of these things that might be called upon. I don't want to overstate this. They may be called upon, they may not be, but all of that contributes, all of this science up here and experience contributes to this box down here that says we recommend these kind of ranges. Because we can find the studies, or dozens of studies in some cases, that say that 2% or more lactic acid is going to be effective. That say that 55C is a effective temperature, or 45C, or 20C. We can really, it's easier to justify something's effective than it is to say it absolutely won't work below this level. That's harder to prove. Questions about that? I feel like I'm making the point well, but maybe not.
No, maybe not.
Okay. So parameter setting is going to be important. Here's some information on regulatory approvals. This is not exhaustive. This is an example. It's mostly, as you can see, Latin American countries. This is where we're doing the most business in these countries, in the U.S.
Rob?
Yes.
Why don't you make it larger your screen? Because I think it's quite small, right?
Well, the reason I can do that, but then the page cuts off, right? So you
okay. Yeah, but on the top, on the screen, on the top, just beside the red, Did you click it on that? Because I think
Just beside the red?
yes. Yes.
Yeah, that's as big as it goes.
Okay.
Yeah.
No, perfect. Okay.
Okay.
No, that's okay.
So this just one message for customers is that all of the markets that they're going to do business with are going to accept lactic acid, very widely accepted, even Europe. And Europe doesn't allow anything else besides lactic acid, and only on beef carcasses. So if they have questions, we can help them with that. But the point is, it's a very proven and very widely accepted type of technology. The question that I expect to come up a lot would be, how is this safe? We're putting a, quote, chemical on meat. How is that safe? Well, lactic acid, of course, is part of our bodies. It's part of the meat that we're processing. Mm-hmm. And as you can see here, a typical beef, typically beef has 0.6 to 0.7% is made of lactic acid. Already, that's without treating it with more lactic acid. And so when we're adding 5% solution to your carcasses down there are what, like 300 kilo? What's a carcass weigh?
It's about 18 the meaning is 18 times 15. Do you have some calculation there? 20. It's about 300 kilos, you can say.
Yeah, okay. 270 kilos. Okay. Yeah. So I'm adding 0.2, I'm adding 200 grams of lactic acid to 270 kilos. So if all of the lactic acid stays with the carcass and doesn't drip off, all of it, we're talking about an addition of 0.07, so about 10% more lactic acid on the carcass than it would have naturally. And as you can see, it's only a fraction of what lactic acid is in foods that we consume every day. So not only is it part of our bodies and safe for us to consume, I could consume lactic acid straight. Wouldn't taste very good, but I could do that. Not only is it natural and safe, it's already there, right? It's already in the foods we eat. It's already in beef. So I think they can take trust in the fact that we're using a source, that we're not adding a foreign chemical to the meat that they're producing. So we may run into that with workers that are unsure. Okay. So here's the information about the packaging, how they can receive it from us. Mm-hmm. And Paulo is your expert on how they could order it and any questions they have in terms of if there's damage to the package or anything like that. They should find that information on this page. At least who to get in touch with. Okay, titration. Did you go through this with anyone else already? How to measure the concentration?
I just sent to Minerva.
I'm asking Marcelo. Does he know how to measure the concentration?
Repeat, please.
Do you know how to titrate or measure the lactic acid concentration? So in the plant is going to have to take a sample every 1 or 2 hours to know that their concentration is within the limit.
Ele está perguntando qual é o limite da concentração do ácido, Paulo?
Não. Ele quer saber se você já trabalhou com kit assim de...
No. I didn't work with this kind of the kit.
Okay, so I will show that to you, and Paulo will show that to you when we're at JBS. Mm-hmm. But the idea of it is that you take, there's a chemical called phenolphthalein. And when it's acidified, when it's in a very low pH environment, it's clear. Yeah. And when it's in a neutral pH environment, it's pink. Mm-hmm. So you put that you take a sample of lactic acid, and you put the phenolphthalein in there as a marker. And of course, that sample of lactic acid is acidic. Its pH is around 2.2.
Okay.
And you're going to neutralize that lactic acid phenolphthalein mixture by adding sodium hydroxide. So sodium hydroxide is a base. When you drop it in there, all of that hydrogen that's forming the low pH acid is going to react with the sodium hydroxide and form water, which of course is neutral. And every drop of sodium hydroxide is going to raise the pH slightly. So it's going to go from 2.2 to 2.3 to 2.5 to 2.7 to 3.1. It's going to keep climbing every drop. When it reaches neutral, you're going to know because the vessel that you're holding with the solution in is going to turn pink. And so what your customer is going to, you or your customer are going to do are there, oops, I thought the table was in
Yeah,
here.
these systems I saw.
Okay, so there's a table in here. So as you add when it goes to pink, and you're counting 1 drop, 2
Yeah,
drops, 3 drops. So
we
the
use
number of drops divided by 10 is the concentration. So if you add 40 drops, it's 4%. If you add 42 drops, it's 4.2%.
okay, we have a same system for water treatment here in Brazil
Yeah.
for test some
Okay.
places. Okay.
So that's how it works. I thought we put the chart in here. Oh, this is in the. Maybe this is in the wrong order. You should have switched the order. Here it explains it. Here's the chart. Okay.
Okay.
Yeah.
So here's the. So how do we get that? Solution made in the plant? Well, you're going to be starting with an 85% lactic acid, and you're going to pump it into a stream of pressurized water.
Yeah.
And that stream of pressurized water is going to go to the cabinet and spray it on the carcass.
Yeah.
And so we just need to pump the lactic acid into the pressurized water at a dilution, at a preset rate of dilution. So it's basically, what is it? 5%. So it's 1 part water, 19 parts. 19 parts water, 1 part lactic acid. So this is a drawing of typical equipment where the pump is measuring the flow of water. It's injecting the lactic acid stream at a ratio of 1 to 20 or 1 to 19, and then it's going out to the application cabinet. And there are various valves and devices on here to measure pressure or measure temperature. Remember earlier we talked about the critical control point in the HACCP plan. It may say, it'll say the pressure, it'll say the temperature, and it'll say the concentration. Well, where's the pressure going to come from? You're going to look at a pressure gauge. Where's the temperature going to come from? You're going to look at a temperature gauge. Where's the concentration going to come from? You're going to take a sample and run the test. So the QA needs to have those gauges somewhere in the stream so they can take those measurements. And they're going to have a sample port somewhere in the stream to take those measurements. The regulation in Brazil says that, correct me here, Paulo, but I think it says that the lactic acid concentration must be controlled.
Yeah.
Okay. So I think we have to understand ourselves and with customers, what does it mean controlled? Because this is how we do it here. And we verify that it's controlled based on taking those tests and say, well, if it's always between 2 and 5 every single day, I've controlled it. Some might interpret that there's an automated way of doing that, like an in-stream device that gives feedback that tells the pump to increase or decrease. And I think that's possible in the future, but that's not where we need to start. Because if we start with those things, it's going to be an accident waiting to happen. This chart gives you a rate of exchange between the lactic acid and the number of liters that are being sprayed. So if the plant processes 200 cattle per hour, we would recommend a spray of 800 liters per hour, which would mean that we have to have, let's say we're doing 3.5%, we're going to consume 33 liters of FCC 85 per hour.
Mm-hmm.
If we choose 4%, we're going to consume 38 liters per hour. Is that clear?
Okay, for example, 4 liters of solution per carcass, right?
Yes.
Okay.
So we just need to know the line speed, and then you can kind of look at this grid and come up with an approximation of how much product we're going to mix into the stream.
Mm-hmm.
Okay, we talked about this already. That's the titration. We may have questions about materials that they can use to handle the acid. And so I've got a page on that. Basically, there are higher grades of stainless steel can survive the acid, and lower grades cannot.
Mm-hmm.
This is my concern, frankly, with Concreta, is that they have a very cost-efficient system, but are they using the grades of steel that will not turn brown and rust quickly in the plant? So we want to be, we're providing this information as recommendation, and we're not necessarily building equipment for our customers, but they can use plastic, works really well. High-grade stainless steel works really well. And even though the left-hand side and the right-hand side of this grid they read the same, certainly 85% lactic acid is going to be much more corrosive than 5% lactic acid. So the time to 5% is going to corrode slowly, 85% is going to corrode quickly if we use the wrong material. Here's more on the materials of construction. Mm-hmm. This is a corrosion table, so it gives you the how much material will get corroded over time. In the case of this is the same steel, but if we're passing it through hot 40 to 80 C, and certainly our 55 C would be here, then we would expect 1 millimeter per year corrosion. Whereas if we're passing it through cold, we don't expect any corrosion. That's on our recommended material. So all materials will corrode at some rate, but both of these I'm told are kind of reasonable rates of corrosion, livable rates. That is the end of this. So, questions?
Mr. Rob, we have a safe distance between the LA area and a whole area of factories or not? Did you understand?
Safe between the intervention and what? People?
No. For example, normally in Brazil, the factories is hold. A lot of factories in Brazil
I'm confused. I'm not clearly hearing what you're saying. In Brazil, they are. Say that again.
Okay. For example, we have equipment of the LA. Okay.
Yes.
Near, for example, 3 meters, we have iron of the camera. We have a safe distance between LA and iron. For example, how can I say?
Yeah, so I think what you're asking, you're talking about like the drum container?
I don't understand.
You're talking about the tote and the drum where we keep it?
Não entendi, Paulo, me ajuda aí. Alô?
Eu não entendi o que você perguntou.
Por exemplo, tem uma cabine aí, certo? Existe uma distância de segurança entre a cabine e uma área que tenha ferro, por exemplo, as portas das câmaras? A corrosão pode ocorrer?
Robbie, he's talking some technical part. What there is what is the risk with regards to some parts to suffer the corrosion from the lactic acid. For
Okay,
instance,
I understand the question. Let me answer it. Okay, so the dilution system and the tote that you're looking at here. So this part of the process where we make the diluted lactic acid.
Okay.
This drum or tote, this vessel of lactic acid, and Paulo can support this, is not it's not volatile. It doesn't create a mist. It doesn't exit its container and drift naturally. So if you have a glass open of lactic acid, you will certainly smell it. So there's a little bit of that, but it's not like vinegar or other chemicals that would very readily PAA, very readily leave the container and drift off onto iron surfaces and corrode them. So I'm not really concerned with any distance between where we store the lactic acid and iron in the room where we make the dilution.
Okay.
Now when you get, let me finish. When you get to the cabinet, and especially if you've heated this solution up, it will drift because you've now sprayed it into the air. And so we want to make sure that the cabinet does a good job of capturing all of that airborne lactic acid spray. And we talked about this yesterday, and it has a stainless steel floor and a stainless steel drain. Now that drain is probably going to go to an iron pipe. And if there's not some water added to it, it will corrode that iron pipe. So typically what happens in plants is that all of these drains feed together, and the lactic acid is going to spray on the carcass. It's going to go into this stainless steel container, and then that's going to drop down into a trough or a floor that collects with other waters and blood and other material that's going to go into wastewater. And so we're really counting on that dilution factor happening. And you've been in the plants that I've been in Latin America, hopefully are representative, but certainly plants here use a lot of water to wash things, to sanitize knives, to clean up the floor and push debris to the drains. There's blood. There's a lot of dilution material in the plant that when you add the intervention chemicals, they go from 5% concentrated to 0.05% concentrated, and they're harmless.
Okay.
So that's an important piece, is that we've got to, if we're going to handle the drainage material with iron pipe, we need to have some source of dilution water.
Okay. Thank you.
Did that answer your question, Paulo?
Yes. Actually, it was not the real thing that Marcelo asked, but it answered, right? Because you told that if you have a good cabinet, there is no risk to this lactic acid split to all the environment, right? It will be very close.
The number one complaint we're going to have is that this cabinet is probably sitting on a concrete floor.
Yeah.
And the carcasses are going to pass through it, and then after they've left the cabinet, they're going to drip. And that lactic acid drip, it's only a few drops. And when it lands on that floor today, you won't notice it. And tomorrow, you won't notice it. But a year from now, that concrete is going to start to corrode. And concrete is nothing more than rock with mortar mixed, right? So what happens is the mortar corrodes away. I don't know if I have pictures of this. Maybe I do.
No, it's clear, Robert. Yeah.
No, it's clear for me too.
Yeah. So you're going to see, and the plants may already, because of their cleaning chemicals, they might already have places like this where they're corroded. But eventually, it's going to eat away, and that's the number one complaint we get is it corrodes equipment. So I want to say that the cabinets perfectly contain the lactic acid. The two things to look out for is how much drips off the carcass after it leaves the cabinet, and what's that floor look like, and how much does the mist drift on the, hopefully not the workers, but on the equipment around the cabinet. Those are the two areas of concern. There are epoxies, there are materials that you can paint on the concrete to protect it, like a coating. And we can provide those.
Okay. I think it's
so
good
if there's an area that they know, my recommendation would be, for 2 meters after the carcasses, 3 meters after the carcasses leave the cabinet.
Okay.
You can buy this coating and put it on there. That's good. That's better.
Okay, thank you.
It's not going to be very expensive to do that, and but we don't want to pretend that it won't be an issue. It'll be an issue somewhere.
Okay.
Okay.
Clear.
Okay. Okay. Let's look at our agenda and see what else did I fail to cover. That's not the one. So we talked about dilution systems. Oh, we didn't talk about quality effects. So yesterday I showed you some pictures.
Yeah.
So this is a picture of a carcass that has damage from lactic acid. It's some would call it brown. Sometimes it's brown, sometimes it's black, sometimes it's green.
Green or gray.
Yeah, or gray. It's bad.
This is a Brazilian carcass, right?
Pardon?
What factory did you do this test?
This isn't a test. I think I actually took this with Laura in Argentina.
But I think Brazil.
I don't take cameras into beef plants here.
Yeah, okay.
So Laura might have actually taken this picture. I think I took this in. I'd have to look at the date of the picture and compare to my calendar.
Because I'm checking the label. The label is Brazil.
One way I can tell this is not an American carcass is we have fatter cattle.
Yeah.
Yes.
And so we have less of an issue with this problem because for two reasons. Our cattle are fat, so they don't have as much exposed blood. And the second reason is that when they do discolor like this, we always trim the fat off during the I don't know if do you know the term fabrication? Fabrication is our word for the butchering. Mm-hmm. The deconstruction of the carcass into individual parts. We call that fabrication or butchering, if you will. So during the butchering, our American consumer will not accept fat on meat, so they'll trim it off really trim. It's ironic. I was in Europe last December, and you look at raw meat sold there, and it's got a lot of fat on it, but it doesn't have any marbling. It doesn't have any fat in the muscle. Yeah. And we have the opposite. So we feed our cattle to be very, very fat and very marbled. Not like the Japanese quite as much, but towards that. And then we completely trim off all the fat on the outside. So at the end of the day, you probably consume the same amount of fat either way. It's just whether it's on the outside or on the inside. Anyway, my point here is that we don't worry so much. Our worry about this problem is that the inspectors, if they see that, they confuse it for surface contamination, and they want it trimmed off, right? It's not so much that the end user, the customer, is going to see the color problem, although that can happen. It's more likely that the inspector is going to be confused that this is feces, or more often they're going to think it's digesta coming from the guts, the stomach, spilled on the carcass, which is, of course, not allowed, and they have to trim off. So the way to prevent this is to make sure the carcass is clean, that's well washed. And usually you find at the end of the process there's a carcass wash cabinet that we talked about yesterday that has the high volume of water and the nozzles are moving, and it's like a car wash. It's meant to get all the blood and debris off the carcass, and then to apply the lactic acid afterwards.
The second thing we can do is we can lower the concentration of lactic acid to 2%, 3%. Usually we don't have problems with that. You get up to 4 or 5%, you have more problems. We're not able to do experiments to really study this in the plant. And so it's kind of the challenging thing for us to solve, because we want to solve it with different buffering acids, and yet we're not at ease to make a model that represents a newly slaughtered carcass, because blood, it goes through, blood changes as it dries, as it oxidizes, as it goes through the process, and this is when it's just freshly coming out of the animal, and we have a hard time mimicking that in the laboratory, so it's a difficult issue to work on. But our recommendation is, and we do have, by the way, we do have studies to show that lactic acid does not discolor carcasses. We can show science. Actually, Texas Tech did some work with us, and we weren't able to measure a difference in carcass color based on use of lactic acid. So we can show that that's true, and yet an experienced customer will say, yeah, I've seen this before. It happens occasionally. I expect it to happen in Brazil, and we just have to do all that we can to make sure that there's not blood on the surface.
I think this is the challenge that I was discussing with Marcelo, right? How to avoid the blood on the surface.
Paulo, this picture, we have a female carcass, okay? And normally, female on the truck suffer more. In the picture, we can see in strip line, we have a impact of the truck.
Okay.
Okay.
It was a kind of a hurting during the transport of the
Yeah. For example, normally the female has more problem with the male. Look at the color of the fat is yellow. I am sure this carcass is female and suffering in the truck.
Okay.
You're basing the judgment on that based on just the muscling or lack of muscling? How do you know it's female?
Não entendi, Paulo.
Como você sabe que é fêmea?
First, because the label. This carcass is Brazil. Okay. And in the bone too, we can see a little cupim em inglês, como é que é?
I don't know. How can I say the part over the loin here? It's a kind of I don't know how to say.
Yeah, in the bone to inside the ribs, we have a label and a bone inside the carcass. Okay.
Okay. So this must have been taken in Mozarlandia then.
Yeah.
Or I believe this is Renata gave to you. It's not true. This is not regarding the Renata stud from JBS.
Well, these are my pictures. So that was taken in Mozarlandia.
Yes.
Right next to it. So I bet this is that's Mozarlandia, right?
Yeah. Okay.
Yes.
I'm just guessing because these are my pictures from it's right next to the picture. I probably took this.
Yeah. I didn't remember that you took some picture in Mozarlandia.
So one thing you were asking about, Paulo. So this meat right here on the surface, we call this rose meat. That will not even though it's red, it's muscle, it's exposed. That will not discolor. But if you cut it and it starts to bleed or exposes blood, then that could discolor. So you were talking about was it Marfrig or Minerva? Marfrig, right?
Yeah, Marfrig has a problem, right?
So that's where one of the things that we have the advantage of with our hide pullers is we have a lot of fat. And when you pull the hide off of, it's like peeling an orange. Certain oranges that you have a really thin skin, I peel them and my fingers get orange juice all over them, and I spray orange juice in my eye. They're really hard to get the peeling off. And other ones have a really thick skin, and they're really easy to take the orange peel off and never get juice on your fingers. In a similar way, carcasses that have a lot of fat on them, the hide comes off rather easily. And so you don't get into all these damage issues. So I look at this and I think, gosh, they really, and you're probably right. There's probably some bruising going on here. There's not a lot of fat that I think they have a mechanical puller in Mozolandi, I can't remember, but there's been some ripping of the surface that we wouldn't otherwise see, which could cause some greater issues for discoloration. You know, the fact that the fat is yellow is also indicative of grass feeding, and we don't have that. Yeah. So part of that's kind of our benefit here is that the cattle have a yellow fat to begin with. I have seen where in Argentina, it was very stark, where they applied some lactic acid and the carcasses went from a very white fat, they're probably grain-fed animals, to a yellow fat. But I don't think you'll see that in Brazil because of your grass-fed situation.
Yes. Mm-hmm.
Yep. Yep.
No, that's okay. For this case, Marcelo is in contact with Marfrig, just trying to understand better what is happening. And after that, we can try to discuss a little bit more because Marcelo is trying to get other information, right?
Yeah, okay. Well, Mr. Rob, do you know Elaine Bedeski of Marfrig?
No, he didn't. No.
No, okay, I will try to do a meeting. It's possible with Elaine because today I spoke with some people on Marfrig, and the last test of Marfrig a few years ago, they don't like it of test because the color, because the smell. I told with Kellen today. Kellen told me that the big problem too is the smell of the carcass after LA. Kellen will send me the reports that time, and I will read and send it for you.
Okay. Yeah. So one thing this is a bit of a challenge. So with Bossum, so forth, we were talking about how sensitive the inspectors are likely to be. Mm-hmm. And also the quality people are going to be very sensitive. So anything that goes wrong, color, micro, it's going to be blamed on the lactic acid initially.
That's for sure, because it's totally new, right?
Whether the best course is to apply 2%, which will do the least discoloration, and maybe run a risk that the validation won't go well the first time, or 5%, which will give us the best chance with the validation, but also produce the most noticeable results on the color. And that's a conversation I think we should be having with Renata.
Yeah.
My recommendation would be to start with 2%.
Okay.
Get through a validation and then make adjustments after the validation. But Renata has knowledge and maybe some local wisdom with respect to how the different stakeholders are going to view this. So it sounds like we're likely to do the JBS start March 25th. And so if there's any Marfrig facilities near Campo Grande, that might be an opportunity to meet with them.
Not very close because the technical people are located in the middle of the way, right? But we can try. Yeah. The best, I think we will have an idea during the post show during our meeting with them. No. Sorry. I make a confusion. You're talking about Marfrig, I'm talking about Minerva. Sorry.
Yeah. So no, for Minerva, Paulo, I need to get those names to Marco Sanchez.
Yes. After that, I would like to talk with you regarding this visit because they just sent me the itinerary, and I believe the day that you suggested it would be not possible because they will arrive on February 6th on United States.
All right. Well, let's. Why don't we have that conversation now? But I want to give Marcelo and Alejandra the final questions or freedom to leave.
No, for me it's okay.
Yeah. Okay. Okay, so let's thank you, Marcelo. You can stick around, but we're just going to talk about a tour of Minerva people to a USB plant. So
Okay, thank you, Rob. Thank you for everything.
Thank you.
See you next time.
ciao.
Tchau, tchau.
What is Portuguese for goodbye? I can't remember.
Adeus or ciao.
Ciao.
You can say
That's
ciao.
international. That's why I use
Yeah,
it.
it's the same
Okay.
of Italian.
Tá bom, Paulão, um abraço. Daí a gente vai se falando.
Abraço. Tchau,
Tchau,
tchau.
tchau.